Comes on everyone. Let's start off. So last thing we did was parallax theorem. Great. Like I said, the proof is really not that important, so we'll just skip the proof part. We're more interested in seeing how it works out. So the next thing is perpendicular axis theorem. So perpendicular axis theorem, right? The main important thing in this is valid only for planar bodies or sheets. So if you have a sheet, let's say this is X, this is Y, and this is Z. So the theorem states the moment of inertia about an axis perpendicular to the plane is equal to the sum of moment of inertia of the two mutual perpendicular axes in the plane. So remember this thing like, this way. IZ is an axis perpendicular to the plane. You can choose anything as XYZ. So this is an axis perpendicular to the plane. Whereas X and Y are perpendicular axes. These are the axes in the plane which are perpendicular to each other. You can clearly see here. First of all, see, suppose if it's a 3D body like a sphere or a cylinder or something, does this even make sense then? For a cylinder, can you draw two lines in the plane? What is the meaning of a plane of a cylinder? It doesn't make sense, right? So that's the easiest way to remember, like, boss, the reason why it is only valid for planar bodies. You want an axis perpendicular to the plane and the other two should be in the plane. Whereas for a 3D body, there is no meaning of axis in the plane. A 3D body won't have a plane as such. So this is the thing which you need to remember. So these are the two theorems that we have. Let me show an example how it works. So calculation of moment of inertia, we have two ways. One, using calculus. Second, using the two theorems. Did anyone try to find out how to take elements for that ring? Did anyone try? Last time I was telling you, remember? Moment of inertia of a ring without parallax theorem, this one. Did anyone try? Forgot. How do you choose elements about this thing? Try. Next class we'll see. Prove this result using integration. It will be a good experiment. You can try. Clear with this theorem? Let me show an example. Let's say we have a ring and someone asks you to find moment of inertia about this axis. We want to find I about this axis. About an axis along diameter. So how do you know which one to use? Should I use parallaxes theorem or perpendicular axis theorem? Idea is pretty simple. Think of like this. Whenever they give you a shape, you know something about it, right? For example, if the moment I say ring, for a ring, what is the standard result? Moment differential about the center. This is the standard result. So this I know. Now you need to understand what am I asking you. If I ask you find about this axis, now you tell me. I know this axis. I'm asking this axis. Are they parallel or perpendicular? Parallel. So use parallax theorem. Suppose if I ask you this axis, are they parallel or perpendicular? Perpendicular. Use perpendicular axis theorem. Simple. So you always see what you know, and you always see what is being asked. Check whether they're parallel or they're perpendicular. If they're parallel, use parallax theorem. If they're perpendicular, use perpendicular theorem. Fair enough. That's a simple way to remember. Like sometimes you have to use both. We will see. So in this question, right, this is what we do. This I know. Let's call it Z. So IZ is given. You are asking me to find about IX. Draw one more perpendicular line. Y. So from the perpendicular axis theorem, IZ is equal to Ix plus Iy. I know Iz is mr square. Here Ix is equal to Iy because it is symmetry. If you see the axis about x and y, it is symmetrical, so moment of inertia will be same. So this will be 2 times Ix. So Ix is equal to mr square by 2. Easy. Have a look at this. Let's see some questions. Let's see. Let's say we take a disk about this axis. Square plate about this axis. Mass m, side m. Get them. Okay. First one mr square by 4, no record. Right, Adrit Arjun. Nee, Ali, that is wrong. Now look at the A part, okay? A part, you are asking about an axis in the plane. I have an idea here. Tell me what is a. I'll show you two ways, okay? So tell me which one is the right thing. So I have a disk here, disk here. So first thing you should know is, okay, for this shape, what do I know? For this shape, I know this thing, isn't it? I know this one. Iz is mr square by 2. Iz is mr square by 2. So my first idea is this. I will use parallaxes theorem from here to here. Let's call this point A. So this will be IA perpendicular. This will be mr square by 2 plus mr square. This will be 3 mr square by 2. Here, first I will use perpendicular axis theorem. This is Ix, which is mr square by 4. Same thing, this one. So I is mr square by 4. Then my idea here is I will bring it to the plane. So here this would give me, so IA parallel is 3 mr square by 4. So about this now if I use parallaxes theorem, so IA will be mr square by 4 plus mr square, 5 mr square by 4. I got two different answers. Which one is right? So here what I did first, I used parallel, then perpendicular. So here I used perpendicular and then parallel. What do you guys think? Most of the time it's not always about getting the answer. COM problem? What do you mean by that? You should know what kind of goof ups also you can do. If you know what kind of goof ups you can do in the exam, you will be much, people say na sir, I did a silly mistake. Silly mistake करके कुछ नहीं होगा. You're just being careless. What do you guys think? First one. Right, Anusha. We have one answer. Anyone else?
The first one.
Message ना reason क्या है? First one क्या है? Answer. First one, second one, you can say anything you want. What is the reason? Message me the answer. Right. The problem here is when you took this one, this Iy and Ix, there's a symmetry here. Ix is equal to Iy. So this is fine. This one is wrong. Reason, when you took this line here, perpendicular axis theorem, this is Ix and Iy, you can't do this. The theorem is right. Ia perpendicular is Ix plus Iy, but here Ix is not equal to Iy. There's no symmetry. So you can't solve. The mistake here is making it half. Clear? So this is wrong. So this you can't solve with this. This is the right method, 5 mr square by 4. So you have to be careful. When you use perpendicular axis theorem, make sure that Ix and Iy are symmetrical. If they're not symmetrical, the theorem is valid, but you can't use it. Is this clear? So you can reach that point A parallel through using parallel then perpendicular or perpendicular and parallel. But perpendicular and parallel will work. And unfortunately, both the answers will be there in the option. So be careful. Now, right. And what about this one? This is easy. For a square, I center of mass is ma square by 6. This is the perpendicular distance a by root 2. So I about this corner is equal to 2 by 3 mr square. Ma square by 6 plus ma by root 2 whole square. Clear? Just use single parallax theorem and you're done. Any doubts on this? I hope this was clear, right? Why you can't use one and why you can the other one works. Because giving you the right answer is easy. You will say, okay, okay, okay. But sometime later you will try to do this and then you'll get stuck like, why is this wrong? And unfortunately, if that option is there, you'll mark it without thinking. Half desk. Theta axis is in the plane. Half desk. Mass and radius are. Solid hemisphere, mass and radius are. Your seniors are weird people, right? They have weird doubts. Sir, I took my photo for this JE application form without glasses, but I wear glasses. Is that a problem? I said, "Blood." Well, if you wear glasses every day, if you're going to the center with the glasses, take photo with the glasses. No? I said, there is no, generally, even with or without glasses, do you look different? No, sir, I look same. Then I said, what is the problem? So just take the glasses and go. If they say glasses an objection, open your glasses and show them there. This is my face on the photo. Seriously, what is the problem? क्या करो ना सीनियर्स के साथ फिजिक्स में डाउट्स नहीं है अभी दे हैव ऑल दिस काइंड ऑफ वियर्ड डाउट्स नाउअडेज yeah even yesterday also we had a speed test for them 90 questions 1 hour highest was 78 right 7 wrong so this is the 7th speed test for them so yeah so far it is fine questions will be slightly main से थोड़ा कम level but ठीक है what is the answer for this thing half disk see first one like I said remember in the beginning we wrote a statement as long as you keep the orientation same it doesn't matter where you keep the particle so using that logic just make this into a full disk can I do that reason if you see here, when you made this into a full disk, what I simply did, right? If there's a point A here, I just took this into point A. If this was point B, I took this point B here. So I simply sliced the disk horizontally. Are you getting what I did? I opened the disk. So I got two half disks which become full disk. Did that mass distribution change? This point ka perpendicular distance is this. When I kept this point here, this is the perpendicular distance. It's still the same, right? This is the perpendicular distance, this is the perpendicular distance. So by making this half disk into a full disk, right, the mass distribution still remains the same. So we can say like this thing, expand the half disk into a full disk. Generally, what people do, right? They say, let's put one more disk of mass m. You can do that, but I don't like it because when you put one more disk of mass m, this will become m and m. Mass will become 2m. Then you have to do calculations with 2m and then do all that. That's a confusion. Best thing would be make it m by 2, m by 2, two half disks. Make sense? So expand the half disk into full disk. You can do this because mass distribution does not change. The perpendicular distances remain same. Think about it. See, this piece and this piece, aren't they identical? So it really doesn't matter if you split it into two parts. So what is the moment of inertia of a disk about the diameter? Therefore, I is equal to mr square by 4, independent of theta. Make sense? It doesn't depend on theta. What about d part? Same logic. What we do here, again, expand this into a full sphere. So basically, if this was A, this is also A. Did the distance change? No, right? So this is basically m by 2 full solid sphere. So expand this to solid sphere. Now you have to be careful. Huh? You can't do this every time for everything. For example, can I do the same thing for this guy? If I had kept the solid sphere like this, can I do for this? Because if I expand like this, did you observe what you did? This point and this point, are the distance the same? So you can't do for this. So when you expand the disk or whatever, you have to make sure the perpendicular distances don't change. As long as you satisfy that condition, we don't have a problem. So about this axis, moment of inertia is 2 by 5 mr square. They use parallaxes theorem. So I will be 2 by 5 mr square plus mr square. Check. Won't both of them? I'm expanding the half shell into full, na? So it is m by 2, m by 2. I'm not changing the mass. I'm keeping the mass still the same. Normally, what you can do, na, Anika, what people do is they'll say, let's put one more. Then the mass will become 2m, na? So 2 by 5, 2m r square. You have to calculate with 2m and then make it half. I don't like that because there's a high chance somewhere you'll forget to put 2m. I have seen that people goof up that 2m ka term. So best thing, always take this and expand into full. That way mass will remain same. You'll not get any errors. Have a look at this. Easy, clear. Let's see one more. Turn in the page. Square plate MA. This is the center. This is the axis in plane. Axis passing through the center of the square at an angle theta. This is an axis at an angle 15 degrees passing through the corner. Find the moment of inertia. Yeah. Try. I'll give you 2 minutes for both. Square is special. Right. Some of you got it right. Ali, Anusha, Yasha, Lakshika. Yeah, you all four got it. See, square, right? If you observe, if you take this axis and if you draw a perpendicular axis, observe both are same. Example, what do you mean by same? For example, see for this piece, I didn't draw it properly. Meaning if you have a chocolate like a square, no matter how you cut it at the center, right, you always get equal pieces. But if you try to do this with your sister, they'll start fighting with you. They're like, oh, these are not equal, you're cheating. Karke. So if you, I need to put it a little up. Kind of, yeah. If you observe it, look at this piece here. This piece here, and if you look at this piece here, they're actually same if you observe, isn't it? The red and the green part, they're the same. It doesn't matter how you cut it, just make sure you're cutting it perpendicularly. You'll observe the two pieces will be always symmetrical. And this thing is IZ here. So here if you see IX is equal to IY due to symmetry. So IZ is equal to IX plus IY, perpendicular axis theorem. IZ I know MA square by 6. We calculated last time using the double integration. So therefore IX is MA square by 6, independent of 12, independent of theta. This is a proper mains level question, right? Most people think that somehow we have to use theta. So it doesn't matter. No matter how you pass the axis through the center, the moment of inertia will remain same, MA square by 12. Now do the second part. When you're at an angle 15 degrees from the corner. Try. I'll give you a minute. Nee, Adrit, that is wrong. Lakshika, you got it. Try. 15 degrees. Nee, Aryan, you did a classical mistake. And that will be there in the option. Hmm. This is a standard one. Must have seen this. Right. Most people say that 15 degrees and get scared. See. So first thing, I will draw a line parallel to this. So this I know, ma square by 12 just may be derived independent of theta. This will be always this. The most common mistake what people do, they think this is perpendicular distance. That is a mistake. That is not the perpendicular distance. This will be a perpendicular distance. Half diagonal is not the perpendicular distance. Half diagonal will be perpendicular if it is 45 degrees. So that is 15. This is 45. So the total angle is 60. So the 15 is given so that you get a good angle there, 60 degrees. So this perpendicular distance will be, this will be the perpendicular distance. That would be a by root 2 sine 60. Now you use parallax theorem. So IA will be ma square by 12 plus m into root 3 a by 2 root 2 whole square. 11 ma square by 24. That's what most of you got it. Check. If you have taken a by root 2 as perpendicular distance, you'll get 7 ma square by 24, and that will be there in the option. So the mistake is that half diagonal is not the perpendicular distance. That will be perpendicular distance if it is 45 degrees. That's it. Easy one, but high chance you'll get trapped, meaning that exam ka tension mein you will write that only. Clear? Any doubts on this? Vartika, clear with this? Got it. Adjust your camera a bit. I can't see you. Neil, Vartika, adjust your cams a bit. Maulika, can't see your faces. Do adjust a bit. Make sure your faces are completely visible. Next one. This is a square frame made of rods. It's not a plate. Mass m, length, mass m, length. I want movement of inertia about this axis. Find moment of inertia about an axis in the plane and passing through the corner. It is a square frame made of 4 rods. Ten ml square by 3, 5 ml square by 4, 5 ml square by 5 by 6 ml square, 5 by 8 ml square. Not a single answer is matching. 8 ml square by 3. How do we do this? See, first thing, if you have an axis like this, and if you have a rod like this, remember the result of this?
ml square by 2 sine square theta.
So I'll do the same thing here. So I will take an axis passing through center of mass. Now it is symmetrical for both all of them. So this is 45, 45, 45, and 45. So this will be ml square by 3 sine square 45 into 4, isn't it? There are 4 rods. So this is ICOM. Now I will use parallaxes theorem. Problem is, if I try to do this thing now, if I try to do about this axis, this I will know, but this will be a pain. I have to find about this axis and then shift parallelly. Are you getting it? You always have to shift it from center of mass. You can't shift it from wherever you want. So IA will be I center of mass. This will be the perpendicular distance. L by root 2. Plus mass is 4m. Perpendicular distance is L by root 2 whole square. Don't forget that. When you write md square, m is the total mass of the system. So this guy would be ml square, that is 1 by 2 ml square by 3 plus 2 ml square, 8 ml square by 3. Yeah, someone did get this. Palaksh, you got it. Check. So first find about the center of mass passing through the center and then shift it. That will be easier. Clear? Easy? Next one. I center of mass. This is the formula we have to use, right? Ali, don't you remember this formula? That we did in rods, so you need to go and check out there once. So these are like 4 rods, isn't it then? To find for 1 rod and multiply into 4. That's what happens if you don't refer notes. You need to refer the notes after the class gets over. Next thing. We have an half ring. Mass m, radius r. This is the hinge. So this is the axis. Perpendicular to plane. Meaning, how what will happen if you disturb this now? It will become like this. Are you getting how it will rotate? Ring like this. Find moment of inertia. This is a pretty good question. This will again come in oscillations. There I'll ask you find the time period. This is point A. So find the moment of inertia about the topmost point. See, this is O. So about O I know, right? I is equal to mr square because all are equidistant. And this distance is r. So IA is equal to mr square plus mr square to mr square. No? What? Nah, it is wrong. Blunder. It is idiots. Try it again. That will be there in the option. You'll mark it and come. One answer. Let me ask you. What is parallax's theorem? IA is I center of mass plus MD square. Where is the center of mass? Got the mistake. Karo. I'll give you a minute now. Anusha, Lakshika, I think. Yeah, you both of you got it. Yeah, remaining people messed it up. Everyone should type your answers if you got it. Some of you are not typing your answers. That means either you're not getting or you're being lazy to type your answers. Try. You got a minute. Center of mass. Where is the center of mass of half ring? Hope you guys remember it. Where is it?
2r by pi.
2r by pi. Yep. See, IO to you know. That is fine. So this is 2r by pi. And that would be r minus 2r by pi. So IO is I center of mass plus m into 2r by pi whole square. Similarly, IA is I center of mass plus m into r minus 2r by pi whole square. Subtract them because I don't want center of mass. So IO minus IA is equal to m into 2r by pi whole square m into r minus 2r by pi whole square. IO का value तो I know already. IO is mr square minus ma. This thing can be written as a square minus b square. So this is r 2r by pi minus this thing into r minus 4r by pi. So you end up with IA is equal to 2mr square 1 minus 2 by pi. That's your answer. Check. It's a good one. Anika, what did you get? Others, clear this. 2mr square was a classic trap. Next one.
So can you go back for a minute?
Hmm.
Yes, sir, thank you.
This is a, what is this? Forgot it. Half ring now. Ah, solid sphere with a cavity. Rho is the volume density, radius r. about this axis. This is r by 2. Find I. To mount a finish of a solid sphere with a cavity, where the cavity is passing through the center and the circumference. Answer comes in terms of rho and r. So yeah. Hope you remember moment center mass taught you how to do for cavities. The idea is the same. This is called annular disk. Get them both. Hmm, 25 mr square by 36. Answer is pretty bad though. 29. I don't remember the answer. Aryan, but that is wrong, I guess. Rehan, that is definitely wrong. You won't get such a good answer. I think Nakshika, you might be wrong. Somewhere you're goofing up. You have to be quite careful actually. The masses part. Na, what is the mass of that cavity thing? M by 8. Hope you took M by 8 and not M by 4. It's a volume. 3D sphere tha wo. Don't treat it like a disk. Try, I'll give you a minute more. I think some of you took it as area. Neil, getting everything so far? Clear, na? Hmm. You look tired today. Anika, 31. I don't think that is the answer. Night. 19 by 80, right? Someone got that. Who got 19 by 80? 29 by 80, that is. Let's see. I don't remember the answer properly, but let's see whether you guys did the same. So the idea here is I will take the full sphere minus I will take the small sphere, and that will give me the sphere with a cavity. So about this axis, now be careful about this axis you want. For that small sphere, it is an axis about the tangent. So if you take this mass as m, which is rho into 4 by 3 pi r cube, this will be small m, which is rho into 4 by 3 pi r by 2 whole cube, which is m by 8. That means if this guy is m and r, this guy is m by 8, comma r by 2. नहीं है शायद अच्छा आंसर नहीं आएगा. Now, for this guy, about this axis, moment of inertia will be 2 by 5 mr square. Now, for this guy, look at this. About this axis is 2 by 5, mass is m by 8, radius is r by 2 ka square. This is your I center of mass. And you want about this axis, So for this, we have to use parallaxes theorem here. 2 by 5 m by 8 r by 2 whole square plus mass of the sphere m by 8 into perpendicular distance r by 2 whole square. This is your I2. This is your I1. So here answer will be I1 minus I2. I will leave the working to you. Check whether you got the same or not. Okay, Anusha, that looks right. So this thing turns out to be 57 mr square by 160. M ka value is rho into 4 by 3 pi r cube. You can substitute that. So then you would have got 19 by 40 types. Did someone got 19 by 40? Yeah, so you got it. If you write in terms of rho and r, you get 19 by 40. M and r, this is the answer. So the first mistake you must have done, maybe mass you messed up. Second mistake people do is you're forgetting you have to subtract about this axis. So you can't take about the center and subtract. You have to shift all the moment of inertia about the same axis and then solve. Please check where you goofed up. And if you're done with this, do the second part, annular disk. You have a disk of mass m with the cavity mass is m. Inner radius is r1, outer radius is r2. Any doubts on this page? Clear with this? Maulika, clear with this? Swastika, got this? Vidyut? Vartika? Clear? There. Fine for the annular disk. M square by pi. You got answer without R1, R2. Dimensions are not matching, God. MR square. You messed up, Pranika. Numerator looks fine. Denominator you goofed up. There are no answers today. Neil, no answers. Palaksh, Rehan, Abhinav, today there are no answers from your side. Vidyut, Maulika, Swastika, Vartika, no answers. Try. It's okay. Tough ones you don't get it. At least get wrong answers. That is also good. Means you're trying. See, you can actually write subtract it. Better would be directly integrate. Isn't it? If you integrate, you just have to change the limits, right? You can do with subtraction, but in this case, right, integration is much easier. The distance x, take a small ring. We have done this integration for a disk last time. Dx thickness. So dm will be sigma into 2 pi x dx. So moment of inertia will be integral dm x square. Limits will go from r1 to r2. The result is good. Sigma 2 pi, this will be x cube dx. R1 to R2, sigma 2 pi, that would be R2 power 4 by R1 power 4 by 4. But what is sigma? Mass by total area, which is m into pi R2 square minus R1 square, mass by total area, into 2 pi R2 power 4 minus R1 power 4 by 4. This thing turns out to be m by 2 R1 square plus R2 square. Check. Lakshika, you got a 2. Didn't get a 2, no? Yeah. How to verify the answer? Simple, no? Put R1 is equal to 0. If R1 is equal to 0, it becomes a full disk, isn't it? If R1 is 0, means there's no cavity, isn't it? So in the options, if you keep R1 0, I should get MR square by 2. Yeah. If this was the question, I would guess like that. I will put R1 is equal to 0, it will become a disk. If I put R1 is equal to R2, what do I get? I get a ring, isn't it? If R1 is equal to R2, it becomes a ring. Then the answer should be MR square. So that way I could have guessed the options. At least 2 options will be eliminated. If it's a bits question, then definitely you'll get the answer. Check. Integration is faster here. Sigma here is mass by total area. Here the area is pi R2 square minus R1 square. And that can be written as, a square minus b square is a plus b into a minus b. So R2 square minus R1 square will cancel. Integration is faster. Check it out. Clear? Any doubts on this? Abhinav, clear, no?
Yes, sir.
Adrit? Clear? Rehan? Clear? Arjun, got this? Perfect. Next one? Next one is a good one, right? Next one will be a good advanced question. We have a equilateral triangular plate. Mass M side A. O is the centroid. Find moment of inertia about centroid. Axis perpendicular to sheet plate and passing through centroid. Let's get this. How do you approach this? You can't integrate this. Try. I'll give 2 more minutes. Okay. How did you get that? Can you send me the working? No, Ali, that's not the answer. No, Abhinav, that's not the answer. How are you guys doing this? Listen, there is another way to solve problems, other than integration and stuff. It is symmetries. Quite a useful technique. Now, before that, let's see something about this. When you take linear objects, I is proportional to mass into L square, and we also know mass is also proportional to L. That means I is proportional to L cube. The meaning of this is, if you take a rod of length L, and if you take a rod of length 2L, keeping everything else same, only the length is double. If this moment of inertia is I, this will be 8I. That is the meaning of it. The moment of inertia will be going as an L cube. If you take planar bodies or sheets, basically, I is proportional to mass into side square, and mass itself is proportional to the side square. So this will be something like a power 4. That means if you take a sheet square, and if you take a bigger square, or for example, if you take a triangle only, if you take a triangle here and if you take a triangle here of A and 2A, so if you take about centroid or centroid, any axis, if this is I, this is 16I. If you take 3D bodies, I will be proportional to ml square, m will be proportional to L cube. This will be L power 5. Means if you take a sphere of R and if you take a sphere of 2R, if this moment of inertia is I, this will be 32I. Clear? So depending on the type of body, the moment of inertia will change the dimensions. A cube, a power 4, a power 5. Now coming back to our question. So you took this triangle here. This is O. So let the moment of inertia be IO. So we need to find IO. Okay. Let's make this into a bigger triangle of side 2A. Now from this logic which we got, so this should be how much here? So I for this big triangle is 16 times IO. Now there is a symmetry in this big triangle. If you observe, this big triangle is actually made of 4 small triangles, where this is the O which you want to find centroid, Let's call this thing O1. Let's call this thing O2. Let's call this thing O3. So for this triangle, IO1 is same as IO, right? So what I will do from here, I will use parallax theorem from here to here. This will be A by 2 root 3. This will be A by 2 root 3. Similarly, I'll use parallax theorem from here. I'll use parallax theorem from here. So the moment of inertia of this big triangle is the moment of inertia of these three small triangles, which is IO1 plus M into A by root 3 whole square. Parallax theorem. Because you want to shift about the center, na? Into 3 times because there are 3 triangles plus IO the central triangle. Is this making sense? This is the 3 triangles surrounding, and this is the central triangle. This is the central triangle. But I know the big triangle is nothing but 16 I naught. So this would be 4 I naught plus this would be MA square. So therefore I naught will be MA square by 12. Check out this thing. This is a different kind of technique. This is useful, whenever a shape is given, when you make it big or small, you get a similar shapes. Lakshika did the same. You did something else completely. Send me what you did. You got the answer though. Have a look at the logic. Again, I'll explain the whole thing. Listen, what I did, I took the small triangle component definition. I go about centroid. So the big one about the centroid is 16 times. The big one can be split into 4 pieces: one triangle, second triangle, third triangle, and fourth triangle. The 3 triangles on the sides, the edges, those 3, you have to use parallax theorem about the center. Understand? You know about this point, but I want about this point in the center. So I have to use parallax theorem 3 times. And the center one is anyway there only, so there's no problem. So the moment of inertia of these 4 small triangles will be equal to the big triangle, which is 69 naught. Check. If you know the technique, it looks easy to solve. It doesn't strike generally. You should have seen something like this before.
So you can use this for all the similar figures.
Yeah, symmetries, it works. See now, because from a small triangle, big triangle, you could compare. Now the big one is made of 4 small triangles.
Yeah.
That way it works. You give me something weird, then it is difficult. All clear with this? Previous page here. No? Let's see one more, a little different one. Next one. Any doubts on this page? Clear now, Aryan, with this page? Great. We have a. Let's do one thing. I'll give this as a homework. You try and come. Next class, we'll discuss. This is a hexagon. Mass and side A. About this axis, I want. Hmm. So find one definition about this axis. You can even do this axis also. That is also easy. I can do this axis also. Can I do that? Yeah, I can do that axis also. Chalo, do for all the 3 axes. It'll be fun. X, Y, Z. That will be your homework. For the first one, first is what? This is X, this is Y, this is Z. Nah, it won't work. Na, think about it. If you divide ना, एक triangle ऐसा आएगा, एक triangle ऐसा आएगा. It won't work. Symmetry नहीं है. It will work for Z. ठीक है? Try this thing. So next class we'll discuss this. So this is another type of problems, where we can use symmetries. The next one is quite a good result. Right? This thing ask a lot in mains. You should know how to integrate this though. Solid cylinder, mass M, radius R, length L, passing through the central axis. It's the middle point. Get this one. Result is more important. I'll write it down. Anyway, in the end, we will write a table with all the important results. Derivation is important because exam they won't ask you this. They will say this thing density rho is changing with rho naught x. So you have a variable cylinder. Then you'll get slaughtered if you don't know how to integrate. GMA, the question was this. They said the mass of the volume of the cylinder is constant. Find the ratio of L by R for maximum moment of inertia. So you have to find I, then you have to do maximum minima, dI by dL. So that was the question. But for that, first you should know the result. But the way the papers are coming 1-2 years, say, and there is no surprise if I ask you this result also directly. Let's get this. Integrate. Hey, you got 2 minutes. Answers. Answer is there. I hope you get it. Some people think, sir, why can't I make it a rod? You can't make it a rod because think about it. This was the axis. Do you mean to say this distance and this distance both are same? You can't compress it like a rod because the distance is changing for different points. So this is what we do. This is the axis at a distance x. Take a thin disk of width dx. About this axis, the moment of inertia will be dm r square by 4. Isn't it? Moment of inertia parallel to the passing through this. So dm will be total mass by total length into dx. So this is I about this axis. So I of the disk about the central axis. We have to use parallax theorem. Dm r square by 4 plus dm x square. The main important thing is that you have to find moment of inertia of each element about the given axis and then integrate. So moment of inertia of this cylinder will be integral this one dm r square by 4 plus dm x square, where x limits will go from minus L by 2 to plus L by 2. Substitute. You end up with ml square by 12 plus mr square by 4. The answer, the easy way to remember is this. This looks like a rod plus a disc passing like this and passing like this. It works because the length and radius are independent of each other, just like x and y. Remember double integration when we used to do the rectangle, that's what we used to do, x and y separately. Could have done the same thing here also, it would work. That's how you integrate. Suppose if the density is changing as rho is equal to rho naught x, the difference will be one more x will come here, na, dma. That would have been different. Check how we integrated this. Clear with this?
So the element is a disk, right? So how are you taking m by L up and then into dx?
Same thing, na? Matlab, I took a disk of thickness dx, isn't it?
Yeah.
वॉल्यूम लेना चाहिए क्या? चलो वॉल्यूम चाहिए, मल्टीप्लाई एरिया वॉल्यूम आ गया ना.
Oh.
A gets cancelled anyway, it doesn't matter. Fair enough. So there I'll write it down for you. See, m by pi r square L agreed, mass by volume, pi r square dx, m by L dx. Because see, when you take an element, all the elements have same area, right? So it doesn't matter. Clear, everyone? Next one is a good one, right? It's not tough to solve, but conceptual. Mm, let's do an easy one. Then we will do after the break that one. The moment of inertia if a body is given by I is equal to 3x square minus 2x plus 7. Find the moment of inertia about center of mass. This is an easy one. So good mains level one. That's it. No information, nothing is given. Only this much you know. Moment of inertia about some x coordinate is given by 3x square minus 2x plus 7. Find the moment of inertia about center of mass. Try. You got a minute. Get it, get it. Get me the answer. Twenty by 3. I don't think you'll get such a good answer. Are you getting? What is the catch here? Remember, we wrote a statement last time.
Inertia or center of mass is decreased.
The moment of inertia among all the parallel axes, the center of mass is minimum. So indirectly, it is being asked find the minimum value of this function, isn't it? बस इतना ही करना था. So moment of inertia about center of mass is minimum among all parallel axes. Be careful, that word is important. Among all parallel axes. You can compare only between parallel axes. If you have two perpendicular axes, you can't compare. Examples, I'll give an example. Listen. Suppose if you take a disk like this is passing through center of mass. How much is this? mr square by 2. Agreed? Now, if you use a parallel axis theorem, this, how much is this? mr square by 4. So if I just shift it little bit here, isn't this also almost mr square by 4? Are you getting it? If you can shift it little bit, mr square by 4 plus something little more. Now this is not passing through center of mass. This is passing through center of mass. Isn't this smaller than the one passing through center of mass? The problem here is you can compare only between parallel axes. So if I don't write this word, moment of inertia about center of mass is minimum among all parallel axes. And if I just skip this word, the statement is wrong. Are you getting it? They'll ask you these kind of questions and multiple choice questions in advance. The moment of inertia about center of mass is minimum. Bas ho gaya, you guys will mark it without thinking. Among all parallel axes, the center of mass is minimum. If you take any two random axes and try to compare, it won't work. So therefore, di by dx, that is 6x minus 2 is equal to 0. X is equal to 1 by 3. So I minimum, substitute 1 by 3 there. 3 into 1 by 3 square minus 2 by 3 plus 7. This is 1 by 3. Aryan, you are right, I guess. Plus 7, and that is 20 by 3. You are right, Aryan. How did you get 28, right, God? You got the concept right, you must have the calculations.
अरे से 1/3 जो 3 ले लिया मैं.
Easy? Clear? If you see the question is not tough, but you should know your basics there. Go, take a break, come back by 7:05. Any doubt so far? Anything that you didn't understand, you can ask me. Any doubt so far?
Sir,
Aryan.
so that triangle wala question I did by another method. I sent you the
Equilateral triangle.
हाँ I
Your
sent you the
photos are
answer.
always right and left.
I'll send it again. One
नहीं
second.
नहीं चलेगा ना, फोन रोटेट कर लेता हूँ, रुको. Ta-da. You use parallax theorem क्या?
No sir, I used geometry.
कैसा use किया God?
सर सेंट्रोइड का वो कोऑर्डिनेट निकाला और फिर उसको
इक्वेटल ट्राइंगल है ना, इतना
हाँ
स्ट्रगल क्यों करना है? चलो निकाल दिया देन.
सर उसके बाद वो md² वाले फॉर्मूले में डाल दिया तो उससे आ रहा है आंसर.
अरे these are not 3 particles नहीं है, वो प्लेट था वो. There are infinite particles. क्या कर रहे हो? md² d किसका ले रहे हो? Which particle you are taking?
सर बट अबाउट मतलब सेंट्रोइड का निकालना है तो फिर वो तो एक
What are
पॉइंट
you
ही होगा
talking?
ना.
What are you talking? Moment of inertia का फॉर्मूला बताओ. mi r square
या
summation सो अगर ऐसा है तो डिस्क का क्या होगा बताओ? mr स्क्वायर होना चाहिए ना अकॉर्डिंग टू योर लॉजिक।
या
mr स्क्वायर बाय 2 था, बिकॉज एवरी पॉइंट इज अ डिफरेंट डिस्टेंस ना रे। तो इवन ऑन अ प्लेट ना, इफ यू सी, इतना क्यों? डू यू मीन टू से दिस डिस्टेंस एंड दिस डिस्टेंस आर सेम?
नो।
नहीं ना, देखो ना, अलग अलग ना, एवरी पॉइंट इज अ डिफरेंट डिस्टेंस। कैसा कर रहे हो वो? आंसर आ गया लकीली, बट ही गोव्ड अप।
ओके।
गॉट योर मिस्टेक ना?
या गॉट इट।
श्योर।
So
हाँ गॉड।
in this same question, the triangle one, can we make it a square and then distribute?
यू ट्राई इक्वल ट्रायंगल को स्क्वायर बना के मुझे दिखाओ। इक्वल ट्रायंगल को स्क्वायर बना के मुझे डायग्राम भेजो, देन वी विल सी हाउ टू डू। स्क्वायर को इफ यू कट इट, व्हाट यू विल गेट? इक्वल ट्रायंगल,
अच्छा,
राइट एंगल्ड
okay, okay.
आइसोसेलेस आएगा।
Okay,
गॉड।
okay.
एनीथिंग एल्स? चलो टेक अ ब्रेक, कम बैक विद 7-5। Get this thing. Look at this thing. We got a ring. Cams on everyone. So we got a ring here, and there are two beads, small beads on it, and the beads can rotate about themselves, meaning this bead can rotate, about its own axis. So for this system, so you have a ring of mass and radius r, and we have a beads of small m and small r. Two beads are there. So the beads are free to rotate. So if you rotate about this axis perpendicular to the plane, find the moment of inertia. If you rotate about this green line, find moment of inertia. Two different questions. Let's get this. I hope the question was clear. How was the diagram? This gives you another very important, concept in moment of inertia. Who is missing? Someone left. Okay, no. Look at the first one. First, look at the green line. Green line is easy actually. So when you're rotating about this axis, so about this axis will be 2 by 5 m r square, and then parallax theorem. This is 2 by 5 m r square. So I of the system, it will be m r square by 2. This is for the ring. Remember, it's the diameter for the ring. Plus 2 by 5 mr square. This is for the bead about its own center of mass. Plus m into capital R square. Parallax theorem about the center into 2 times. This is the moment of inertia. Check. What about the other one? Perpendicular one. The second one, this is our catch. The problem here is the beads can rotate only about this axis, but our axis of rotation is this way. So the moment of inertia will not be same about both the axes. So the plane of rotation, the axis of rotation of the beads is perpendicular to the axis of rotation of the whole system. So axis rotation of beads is perpendicular to axis of the system. Do you remember we wrote this statement also? Moment of inertia is a tensor. It behaves like a scalar for a given axis of rotation. Meaning, if all the rotations are about the same axis, then you can add them like a scalar. But here, they're about perpendicular to each other. So here, this is what happens. So moment of inertia of the system will be mr square. This is for the ring. Plus, these beads, right, will simply behave like particles. They'll just go round like this. So that will be m capital R square into 2 times. There'll be no rotation for them. The beads simply behave like point particles. We don't consider that rotation because it is perpendicular. So basically we assume r is much greater than smaller. So the radius is small. You can treat it like a particle. Are you getting the catch? So whenever you add moment of inertia, first make sure, because see now when it rotates this way, this is 2 by 5 r square, right? Can the bead rotate like this? It has to break and come outside then. It can't rotate that way. So for the bead, this rotation is restricted. This rotation is restricted. Bead can't rotate perpendicular to the plane. Clear? That's the difference. Yeah. Clear? Any doubts on this? Ali, Aryan, Swastika, clear? Malika there? Yeah, can't see you again. Do it just your cam. No, that is our different moment of inertia. So let's make a table so that it'll be easy for you to check out the answers. So first thing is the rod. So moment of inertia about the central axis was ml square by 12. Moment of inertia about the edge was ml square by 3. About the center at an angle, ml square by 12 sine square theta. Moment of inertia about the edge and ml square by 3 sine square theta. Moment of inertia parallel, this thing is md square. I was recently talking to a few students and someone is saying, they're making short notes for every chapter. It's a complete waste of time. Don't do that. Because if you try to make a notes out of this, I'm sure pretty every problem you'll find something to write. Literally, you will write at least 30, 40% of the notes you will write again. This is not school. So remember that school mein it would work. School mein you did all those kind of nonsense things. Rewriting notes, making sheets and all that was all bullshit. Logically socho na. Tomorrow when you go to IITs, engineering college bits anywhere, you want to refer something, you will write notes or you'll just go to Google and check the answers. right? So you need to use your time to think and solve more rather than putting time on writing stuff. Maybe chemistry also, right? It would help for you to remember. So you have all the notes pretty detailed. So don't waste your time. For physics, you really want to learn, try to solve more questions. Finish off your basic Laska material, go for Eredo. Sheets I'm sending, my papers, every week there's a paper of mine. You can resolve that paper. That itself is a good assignment. So you have enough questions. So focus on that. That's how you learn physics. Remaining subjects I won't comment, but physics, it never helps. If you're going to rewrite almost 20-30% of the notes, that means you're going to spend aram se at least 2-3 hours. In that 2-3 hours, you could have solved at least 10 to 12 questions. That would actually help you much more. So for an arc, theta, mass m, radius r, ring, hollow cylinder. For all of them, the result is mr square. Sector, disk, solid cylinder, I is equal to mr square by 2. And for the disk now, passing through the diameter, mr square by 4. That half disk. This is also mr square by 4. Hollow sphere, solid sphere. Two by 3 mr square, 2 by 5 mr square. Check. You need to mug up all the results, just like center of mass. Because in the exam, if you waste time trying to derive these results, you'll be, wasting the time. Instead of thinking, you'll be wasting time on deriving this stuff. Mains mein fir bhi somehow you'll survive, Advanced mein you won't have time. Physics ka advanced papers, if you see, right, the papers are solvable, but they take time. This is the most common comment, everyone, every year your seniors say. Sir, physics paper, if I had 10 more minutes, I would have got everything. You'll never get the 10 minutes. So currently, some of your seniors who are already doing mains well, unka advanced, they write the paper only for 2 or 45 minutes. I don't give them 3 hours to write. I tell them, assume your exam is 2 or 45 minutes and write. So for some people who are asking, there are a few people who are asking, sir, mera speed nahi aa raha exams mein, what to do? So when you write a practice paper, right? See, you want speed, it comes only when you write more papers. And for you right now, getting speed is little difficult. Because every time you get strong in one chapter, new chapter comes. Generally, speed improves drastically once the portion gets over and syllabus gets over. But currently, if you want to increase the speed, let's say you finished off your PACE booklet or whatever your classes ka booklet, you finished completely. And let's say you want to solve one more book and you have time. And imagine you're doing Cengage or DC Pandey. So let's say you're doing PACE booklet, finished everything, अच्छे से कर लिया, you took your time and did आराम से. The second book which you're doing, let's say Cengage or DC Pandey, let's say DC Pandey you're doing. Level 1, there are 60 questions. Best thing to do what? split this into 30 questions and 30 questions, put a 1 hour ka timer, write like an exam. Already एक book solve किया ना, you solved one book, that means your concepts must have done something. Now take 1 hour and write it like an exam and see how many you can do. चलो 30 questions 20 questions करो, but put a time limit and try to do like an exam. So you're doing a book also, you're doing it in a time constraint also. The reason why some of you don't get speed is because when you solve an assignment, you take time and solve aram se. Suddenly on the day of the exam, there's a time constraint. You don't know what to do. So if you're solving two materials, material one, solve it normally, like what you're doing right now. Take your time, aram se solve karo. Material two, if there are 100 questions, split this into 25, 25, 25. There you got 4 exam papers. Put a 1 hour ka time. Now see what happens. If I give you the same 25 questions, I'm damn sure you'll do for 2 to 3 hours, isn't it? But the same 25 questions, if I put a 1 hour ka time limit, I'm sure at least you'll do 12 questions. And you must have read all the questions. Now to resolve, it will take another 1 to 1.5 hour only. So you might take less time or even the same time, but now you're solving under time constraint. This would help you to increase the speed. You're getting it. I'm not telling you to do extra. If you want to do extra, you won't have time. So whatever you're doing, you only have to do that better. You're getting the catch. So don't try to do too many new things. Whatever you're doing, try to make that better way. For example, like what I told your seniors, to increase the speed test, right? 1 hour में 90 questions we are writing. Main से थोड़ा कम है. In reading, you know what is the most consuming thing here? Reading 90 questions will take at least 30 minutes. Reading takes time, not solving. That means they get a chance only to read the question once properly. Most of them do, hopeless goof ups. I will say the angle U is projected with vertical angle theta. They take this theta and solve the entire problem, and that answer will be there. So when people say, sir, how to reduce silly mistakes, being aware, and that will come when you do a lot of paper practice. We'll do that, don't worry. The reason I keep a test every week is that only. We write a lot of tests. If you don't write enough tests, you will never improve. 2005, 2006, when I wrote the exam, in 2 years, our principal made us wrote 160 papers. 160 papers in 2 years. So I'm talking about 2006. Getting it? So we wrote so many papers. That's why we always had that speed. But you guys, if you see, right, they keep one test once in 3 weeks or once in a month. So the next shape is, I hope you remember this thing, screen triangular plate. So I about the base. This is a very good result, mh square by 6. And today only we derived it, the equilateral triangle plate. This is actually a little non-standard equilateral triangle. mh square by 12. Now here there is one weird result. We don't have the proof for that, and I don't think they'll ask also, but just in case. Maybe in your classes ka test or something, it'll come. So if you have an axis and if you have any weird triangle like this, plate, the theorem is also pretty bad, actually, the proof, but the result is pretty good. So what this theorem says, you can take all this mass, you can put m by 3 here, put m by 3 here, and put m by 3 at the center of the sides. Put m by 3 at the center of each side. And now if you take these distances, let's say this is R1, this is R2, and this is R3. The moment of inertia of this plate is m by 3 R1 square, m by 3 R2 square, and m by 3 R3 square. Just remember, it's not that important, but just in case.
So why can't just we like concentrate all the mass on the centroid and
It's a square function, right, God?
what's it?
It's a square function. How will you do that? So you mean to say, suppose if I say 3 square plus 5 square is 4 square. It's a square. If you see now, 3 plus 5 by 2 is 4, agreed?
Hmm.
The average will work, but square functions won't work.
Oh, okay.
For example, see, if this particle is here and this particle is here, okay? Let's say there are only two particles. And the formula is m into r. So if this distance was 2 and if this distance was 4, the average would be 3. But if it is a square, 2 square, 4 square is not 3 square. That way. So remember that thing, the centroid ka thing, na, that average thing works only when the function is linear. This is a little non-standard result, right? The result looks nice, so I gave it. So keep it in mind. We still have few more shapes. Then we have our rectangular plate. Then we have square plate. Then we have cube. ml square by 12 plus mb square by 12. ma square by 6. Cube is also ma square by 6. If you compress a cube, you get a plate. And for the square plate, anything passing through the center is again independent of theta. ma square by 12. That is again one quite a good result. And this thing we derived in the end today. Mass m, length L, radius r. ml square by 12 plus mr square by 4. These things we didn't derive, but we can derive them. Hollow cone and solid cone. So here the elements will be rings. You can take an element and integrate. Interestingly, the result will be pretty good, mr square by 2. This is the height of a hollow cone. So here the element will be a disk. Height of a solid cone, 3 by 10 mr square. These are little non-standard, but they can be asked. You can derive them by taking elements. Other than this, we have another two things, weird ones. These are again, they're not in the portion actually, but in case, your institute people have this problem, sometimes they're just randomly give. So the results are not bad to remember, so you can remember it. Because advanced, if they ask you this, they have to explain you some concepts before asking you anything like this. It's an axis passing through the center and it is out of the plane. So this I would be mr square by 2, 1 plus cos square theta. Axis is not in the plane, it is out of the plane. This derivation is pretty bad for these two. We don't need the derivation, just remember the results. So the cones, these two discs ka thing, and this triangle, these 5 are in the equilateral triangle. The 6 are kind of non-standard. If at all they ask you, then that's will be a questions. And this ring and the disc is nonsense. We need to use 3D geometry for that. So it's quite complex. We can do that, but it's a waste of time. Have a look at this. So these are all the results which you need to remember. This is the second one. Like I said, in rotation, there are 3 things. Top, moment of inertia, no slipping condition. You know these 3 things, 60 to 70% chapters in your hands. Angular momentum is a different part. Clear with this? The next thing. Can I turn the page? Next thing. Velocity and acceleration profile of a rolling body. So if you have a disk or a ring which is going with V and omega, a rolling wheel, you can split this into 2 motions. So this is a rolling motion. Well, it's a rolling wheel. So this would be translation. So you assume every point is going with V, and then you assume everything is rotating about the center of mass. So every point is going with V, 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 V. The center is going with V. Even if you take a point somewhere here, this is also going with V. Same thing, if you take this point here, rotation, R omega, R omega, R omega, R omega. This point also will be going in a circle here, R omega. So if someone asks you to find the velocity, so let's say the topmost point is a R.
It will be R omega or distance from the center.
What distance from the center है वो? Small r omega. If you take points like this, right? So now if someone asks you find the velocity of A, so from translation you take this V I cap. From rotation also you take that R omega I cap. So it is V plus R omega I cap. If someone asks you find the velocity of B, from translation it is V I cap, and from rotation it is minus R omega J cap. You're getting how it is? So velocity of any point can be simply addition of translation plus rotation ka components. Velocity of C will be V minus R omega I cap. Velocity of D will be V I cap minus plus R omega J cap. So this is how the velocity of any point would look like. This would be V plus R omega. This would be V this way, and this would be R omega. This would be V and minus R omega backward. This would be V and R omega upward. You do the vector addition. Check it out. Clear? Let's see a question on this. We have a disk here, which is going with V, and it is rotating with 3V by R. So from the center here, there is a point A at an angle of 30 degrees and distance is R by 2. Find velocity of A. Find a point on the disk whose speed is V and in the vertical direction, whose speed is V j cap. Second question I just gave out of flow. Let's see whether we'll get something or not. Find a point on the disk whose velocity is V in the vertical direction. Second is a good one. You can solve it, but I don't know. Let's see. Mathematically, it might become complex. Two questions. I gave you a point, find the velocity. I'm asking you if the velocity of that point is V j cap upward, what is that point? Where is that point? Get this. So velocity profile is simple idea. Velocity of any point on the disk is simply translation plus rotation. You can add it up. I think let me write a statement here. We can split rolling motion into translation and into vector sum of translation plus rotation. You have to add the velocities vectorially. Let's get this. अरे ओमेगा का वैल्यू इज गिवन अर्जुन, यूज इट. Omega is 3V by R. Give me answer in terms of V. Minus V by 2, 3 root 3 V by 2 j cap. Okay, let's see. We have one answer. B part का answer R by 3 from, oh, which side God? R by 3 from where? Up, down, right, left? If you just say R by 3, then there's a full circle there. No? V by 4, 3 root 3 V by 4 j cap. R root 2 by 3, comma 5 by 4. Which answer is that, Lakshika? Second part, okay? R root 2, R root 2. You went out of the disk. R by root 2. If you say R root, and you, okay, by 3 is there. Okay, okay. Let's see. Let's see the first part. I think first part. People are getting different answers. Okay. Idea is simple. So this is A. So it will have two velocities. One translation, which is V. Second, you are going in a circle. So this velocity will be R by 2 omega. This angle is 30. So this angle is 30. So this angle is 60. So at point A, we have velocity v. This would be r omega by 2 sine 60. This will be r omega by 2 cos 60. So velocity of A will be v minus omega is 3v by r. So r omega is 3v by 4 I cap plus r omega is 3v by 2 sine 60 is root 3 by 2 j cap. So v by 4 I cap plus 3 root 3 by 4 v j cap. Please check the signs. Why are you guys adding it up? Rotation is backward. Omega आगे नहीं है gods. Omega is left side. Check ना omega is which way. Why are you blindly taking to the clockwise rotation? नहीं है वो. Who got this? Lakshika, you got this. Ali, most of you got second, but first part you goofed up, I guess, everyone. VI cap, nay. Anika, you messed up the sign. Adrit, you got it. Yeah. Malika, you also somewhere you messed up. Check it out where you messed up. Clear with this one? Get the second part. Find the point on the disk whose velocity is upward. Point only. God. Anika, point O is going right side ना मुझे upward चाहिए God. J cap. I didn't ask you find the point with the speed v. I said find a point on the disk with speed v j cap. The point should have a vertical velocity v. Let's see how to do. I'm more interested in the process. I don't know whether we'll get an answer or not. We should get actually. Later on, I'll teach you something called instantaneous axis of rotation IAR. With that, it'll be easy to find. But for now, let's see how to do it normally. Just to give you an idea, right? Assume a random point. Assume from O, this point is R. And assume this angle is theta. R and theta, they will take care, theta will take care of the signs. Don't worry. You can ask me, sir, how do you know it is in the first quadrant? I don't know. The theta will come obtuse if it's not in the first quadrant. So assume R and theta. So find the velocity of this P. Horizontal component should be 0. And vertical component should be V. हो गया ना? You get two equations, two variables. Ideally, should get the answer. Let's see. So choose any random point at a distance small r at an angle theta and find r and theta. Done. You get the answer. I think we have one answer. So Aditya got r root 2 by 3 and pi by 4. Lakshika, you got r root 2 by 3 pi by 4. Yeah, I think two people got the same thing. Maybe right. Try, others. Give it a try. Take a minute. Same idea. This is V. This is r omega. This is 90 minus theta. So V, this would be r omega cos theta. This would be r omega sine theta. Since you want in the j direction, so V minus r omega sine theta should be 0. R omega cos theta should be V j cap. So that is V. Isn't it? It should be vertical component, matlab horizontal component 0. Horizontal component is 0. So V is equal to r omega sine theta and V is also equal to r omega cos theta. Perfect. Theta आ गया यहाँ से. Divide them, we get tan theta is equal to 1. Theta is 45 degrees. And then V is equal to R omega. Omega is 3V by capital R, and this is sine 45. So small r would be R by R root 2 by 3. Check. Easy only. I thought calculations will be bad. So this point is actually in the first quadrant. I was not expecting that, but okay. So I can play both the ways. I can give you a point and ask velocity. I can give you velocity and find the point. Clear? What happened, Anusha? You goofed up something. Clear? Huh. When I said answer, you are laughing. I thought maybe you did some weird blunder, so you are laughing. It's okay. You can smile randomly also. You did a big blunder. होता है. Clear? Next one. So that is how velocity profiles. The next thing is the acceleration profile. This is good. When you have a disk or anything, let's say this is going with ACOM, and let's say this is also rotating with alpha, angular acceleration. You know how many accelerations each point will have? If you take a point on the first quadrant, this is acceleration of center of mass. This is tangential acceleration, which is R alpha. And this is acentripetal. Because you're rotating in a circle, there'll be centripetal acceleration also. Omega square R. Every point will have three accelerations. You're getting it? A center of mass, A tangential, and A centripetal. So if you take a point here, this would be A center of mass. This would be R alpha, A tangential. This would be omega square R, A centripetal. Omega square R. R alpha, A center of mass. So if they ask you find the acceleration of a point on the circumference, don't write A plus R alpha and all. You have to include the centripetal acceleration. Happens. This thing is omega square R. So keep this in mind. A simple question would be like this. In which quadrant the acceleration can be 0? In which quadrant the acceleration of the point can be 0? Fourth quadrant, na dekho. So 3 can cancel.
Fourth quadrant.
Fourth quadrant. So questions can be framed like that also. That will be a simple theoretical question. In which quadrant the acceleration can be 0? In which quadrant the acceleration can be horizontal? In which quadrant the acceleration can be vertically upward? So you can play around like that. I can simply ask you find the acceleration at any point. That would have been, you have to take the resultant of 3 accelerations. So keep that in mind. So each point has 3 accelerations. Not like velocity only had 2. Centripetal is extra. Each point has 3 accelerations. Clear with the acceleration profile? Next thing, no slipping condition. Look at the word no slipping. We have done this even in friction also. What is the meaning of no slipping? The surfaces in contact have a 0 relative velocity. the surfaces in contact have same velocity and acceleration. That's it. Simple. Remember that thing. Most people have seen, ask them what is no slipping condition. V is equal to R omega. A is equal to R alpha. They say this thing. It's a blunder. The points in contact should have same velocity. Now, suppose if you have a sphere or a disk rolling on a plank. Let's say this is the velocity of the plank. This is velocity V and this is omega. So if I say there is not slipping, you are interested in the point of contact here and you are interested in this point of contact here. Now from the velocity profile, this guy will have V forward, R omega backward, and this point will have Vp. Since it is not slipping, Va equal to Vb. So V minus R omega is equal to Vp. This is the no slipping condition for this case. If the plank was at rest, that means it's like ground. Just to be clear here, this is another mistake people do. They think you got V is equal to R omega because from rotation. This is actually V center of mass minus V tangential is Vp. If plank is at rest, V center of mass minus V tangential is 0. V center of mass is R omega. Are you getting? V is equal to R omega you didn't get from circular motion. What we got here is V center of mass is V tangential. V tangential is R omega. That came from circular motion. So this is the most common blunder. What is no slipping? V is equal to R omega. Don't write that. Always check. The same thing you can do with accelerations also. If this guy was going with AP, this was going with A center of mass, and this was rotating with alpha, then acceleration of A should be equal to acceleration of B. This will be A center of mass minus A tangential is acceleration of the plank. A tangential is R alpha, and this is AP. If plank is at rest, A center of mass will be equal to R alpha. Simple. No slipping condition, meaning at the point of contact, the velocity should and the acceleration should be same. This is the third concept. So next class when we meet, we will do few problems on no slipping condition, and then we'll start off with the actual problems. Now from next class onwards, things will start moving. It'll be fun. But if you understood till now, your basics are clear. You'll be able to handle most of it. The steps are still the same. FBD, constraints, equations, solve. Idea is always the same. We'll just see more different varieties. Okay, so with that, we'll wind up for that day. All right. And the center mass next week test will be online tomorrow. That will be there till Thursday. So you can, I'll post it in the group tomorrow once it is online. And plus, I'll be also keeping 2 practice papers also.